Now we will be focusing on operations with matrices. Before we focus on the operations part, we need to understand matrices and how they work. So over here, I have a matrix A, and a matrix is a system of numbers where you have several entries. In this system, we have three rows, 1, 2, 3 rows, and three columns, 1, 2, 3. So basically, this is called a 3 by 3 matrix. Anytime you count the rows, okay, and this will be your row number. So this will be row multiplied with your column number, and we have three columns here. Columns are from upside down, so we have 1, 2, and 3 columns. So this is also columns. So we have three columns and three rows here. And over here for B, we have two columns and two rows. So we will write the row first. Our row is 2, and our column is also 2. So these are called square matrices because the number of rows equals to the number of columns. So anytime row number is equal to the column number, it's going to be a square matrix. Now let's try to identify the length, the size of these matrices. So for matrix A, we have three rows. Okay, so this will be a 3 multiplied with, and two columns. So we will have a 3 by 2 matrix. This is called a 3 by 2 matrix because we have three rows and two columns. For matrix B, we have two rows, okay, 1 and 2 rows. So this will be a 2 times. We have 1, 2, and 3 columns. So this will be a 2 by 3 matrix, okay? Now let's work on this addition problem. Addition with matrices can only be done with the same size of matrices. So this matrix is a 2 by 2 because we have two rows and two columns, and this also is a 2 by 2 matrix. So we are able to make this addition operation because the length is the same, okay? These are the same length. So if we had a, let's say, 2 by 2 multiplied with a 2 by 3 matrix, plus a 2 by 3 matrix, we wouldn't be able to make this addition because addition requires us to have the same length of matrices. So thankfully this is not the case here, and we are able to make addition with these matrices. So how do we add matrices? First of all entries will be added with its corresponding same entry on the other matrix. So when you want to add the A matrix, this is the A matrix plus the B matrix, 5, 6, 7, 8, we will have on the left upper corner, we will have 1 plus 5. Okay, so this will be 1 plus 5 because every entry will be added to its corresponding entry on the other matrix. And over here on the second entry, if this matrix, the resultant matrix, we will have a 2 plus 6 because these numbers will be added together. We will have a 3 plus 7 and a 4 plus 8 as a resultant matrix. And if we go ahead and simplify and make this addition, we will have 6, 8, 10, and 12. And this is the matrix A plus B. Now let's try to multiply these matrices. Now, in order to make a multiplication with matrices, first of all, we need to determine the size of each matrix. So the size of matrix A will be a 3 by 2 matrix, okay? We have 3 rows and 2 columns, therefore our matrix size is 3 by 2. On the matrix B, we will have 2 rows and 3 columns, so this will be a 2 by 3 matrix. Now, listen carefully. In order to make a multiplication possible, you're going to take the left matrix. For example, in this case, the left matrix is A on the first matrix, and you're going to look at the column number, okay, the column number of A, and then you're gonna go to the other matrix and look at the row number, okay? So the column number of the first matrix must be equal to the row number of the second matrix. So if these are equal, you are able to make this multiplication. In this case, 2 equals 2, which is true. So therefore, we are able to make this multiplication. And another very important information, you checked if these are equal, right? And we determined if they are. Now we know that we have a multiplication and a resultant matrix from that multiplication. So we know that the size of the resultant matrix will be the row number of A and the column number of B. So the resultant will be 3 by 3 matrix. Okay? Now, since we can understand that this is a 3 by 3 matrix because of the number of rows and the number of columns from A and B, we are able to make this multiplication, and we know that our resultant matrix will be a 3 by 3 matrix. Well, now how do we make this multiplication happen? First of all, you're going to take the row from A and the column from B, and you're going to multiply with each entry corresponding to the other entry and add those numbers together. So we will have 1 by 1. So 1 times 1 plus 2 times 4 will be 9. So our first entry will be 9. Secondly, we're going to keep going with this row until we're done with it. So we're going to go and multiply this first row with 2 and 5. So we will have 1 times 2 and plus 5 times 2. And this will be 12. And now we will do the same thing for the third column. So we will have 1 times 3 plus 2 times 6. And this will give us 15. And we keep doing this with the other rows as well. So we're going to take the second row, and multiply with the first column. So we will have 3 times 1 plus 4 times 4. 16 plus 3 will be 19. Do the same thing for 2 and 5. So we will have 3 times 2 and 4 times 5. So we will have 26. 26. And for the third one, we will have 3 times 3 plus 4 times 6, 24 plus 9, and this will be 33. And finally, we will have 5 and 6 row and multiply with each corresponding column. So we will have 5 times 1 plus 6 times 4. That will be 24 plus 5, which will be 29. The third row times the second column will be 5 times 2 plus 6 times 5. So that will be 30 plus 10, which is 40. And the third one will be 5 times 5, 6, multiply with 3, 6. So we will have 5 times 3, 15. 6 times 6, 36. So 36 plus 15 will be 41 and 51. So basically, this will be our resultant matrix for A times B. Now let's solve these problems. So we are given two matrices and four operations we want to conduct with these matrices. First thing first, I want to identify the size of each matrix. So over here we have a 3 by 3 matrix because we have 3 rows and 3 columns. So our number of rows will be first and our number of columns will be second. And likewise for B, we have a 3 by 3 matrix as well. So we are able to make a multiplication because the right number, the column number of A and the row number of B are same. And the resultant matrix will be a 3 by 3 matrix from the number of rows of A and the number of columns of B. So when you have any A times B or B times A multiplication, our resultant matrix will be the 3 by 3 matrix. Now that we have these information, let's go ahead and do these operations. So the first operation is 2A plus B. Okay. First thing, I want to multiply A with 2. So as you can remember, we when we're multiplying with scalar numbers, to matrices, we're gonna just multiply that scalar number with everything inside. So 2a will be equal to 2, -4, 0. I'm just multiplying everything by 2. It's because we are multiplying with a scalar number. Okay, and this is going to be 2a, and that's it. And we just want to add that with b, which was this matrix over here. So 2a plus b will be, we're gonna write 2a first. 2a is this matrix we have on the left, so we're gonna write that down. And we're gonna add b over here. So it's gonna be 4, -2, 3, -1, 5, 0, 6, 1, 2. Okay, and when you're making addition with matrices, you add each corresponding entry with the corresponding entry on the other matrix. So 2 will be added with 4, so we will have 6. -4 will be added with -2, we will have -6. 0 will be added with 3, we will have 3. 6 will be added with -1, we will have 5. 4 will be added with 5, so we will have 9. -2 will be added with 0, we will have -2. -4 will be added with 6, we will have 2. 2 will be added with 1, we will have 3, and 6 will be added with 2, we will have 8. Now we are asked to find a minus 4b. Well, first things first, I want to find what 4b is, so we're going to go ahead and multiply b with 4. So 4b will be equal to, remember, we're going to multiply everything by 4, 1 by 1, 16, -8, 12, -4, 20, 0, 24, 4, and 8. And this will be 4b. And we were asked to find a minus 4b, and a was 1, -2, 0, 3, 2, -1, -2, 1, 3, and minus this matrix 16, -8, 12, -4, 20, 0, 24, 4, and 8. Well, when you subtract matrices, we're just gonna multiply this negative with everything inside in imaginary way, and you're gonna basically add or subtract depending on the sign. So we're gonna get the first entry with the first entry. So every entry is added to its corresponding entry, and we're gonna go ahead and get 1 minus 16 because of the symbol, the minus symbol here. So we'll have -15. -2 minus 8 will be 6 because you're going to add 8 to -2. 0 minus 12 will be -12. 3 minus 4 is 7. 2 minus 20 will be -18. -1 minus 0 will be -1. -2 minus -24, I'm sorry, -2 minus 24 will be -26. 1 minus 4 will be -3, and 3 minus 8 will be -5. And this will be equal to a minus 4b. Now let's try to find what AB is. So as we covered before, we are able to make AB multiplication because these numbers are same, and the resultant matrix was going to be a 3 by 3 matrix. So we're going to have a 3 by 3 matrix here, and we're going to take the row A and multiply with the column B to get the first entry. So the row A is 1, -2, 0 multiplied with 4, -1, 6. So we're going to multiply 1 with 4, -2 with -1, and 6 with 0. So we will have 4 multiplied with 1 plus -2 multiplied with -1 plus 0 times 6. So this will be 4 plus -2 times -1 is 2. So we will have 6. For the second thing, we're going to get this and multiply with the second row for the second entry. So we're going to have 1 multiply with -2 plus -2 multiplied with 5. and 0 multiplied with 1. So we will have -2 and -10 here. So we're going to have -11. And likewise, we're going to repeat this same process with the third column. So we're going to have 1 times 3 plus 0 times -2 plus 0 times 2. 0 times 2. So this will be just 3. Okay. So let's now we're gonna move on to the second row. So every time you move on to the second row, we're gonna do the second row operation. So we're gonna take the second row of A, 3 to -1, and multiply 1 by 1 with the columns of B. So we're gonna have 3 times 4 plus 2 times -1 plus 6 times -1 for this, and we will have -6, -2, and 12. This will be 8 minus 12 minus 8. That's going to be 4. And over here on the second one, we're going to have 3 times -2 plus 2 times 5 and plus 1 times -1. So we're going to have -1, 10, and -6. So we'll have 3 in total here. Let's do the last one. This matrix multiplied with the column will be 3 times 3 is going to be 3 times 3 plus 2 times 0, 2 times 0 plus -1 times 2. So we're going to have 7 in total for here. And now let's conduct the last row. The last row will be -2 times 4. We're going to get the last row multiplied with each column here. Plus 1 times -1 plus 3 times 6. And this will be, guys, -8, -9, just positive 9. And the second one will be -2 times -2 plus 1 times 5 and plus 3 times 1. And this will be 8, and this will be a 4, so we'll have 12 over here. And the last one will be -2 times 3 plus 1 times 0 plus 3 times 2. So we're going to have 0 for the last entry. So this will be equal to AB. Now, finally, let's try to find BA. A lot of you may be tempted to say AB equals to BA, but this is definitely not true. Okay, many times AB and BA will never be the same. Some cases it could be the same, but most of the time it won't be the same. And sometimes you might be able to get the matrix AB, but BA might not be defined because of the size of the multiplication matrices, okay? Like, for example, if you had a 5 by 2 matrix times a 2 by 6 matrix, we would have a multiplication here, but if you reverse that and multiply the 2 by 6 matrix with a 5 by 2 matrix, you're not going to be able to multiply these matrices because the 6 and the 5 are different numbers. So basically, you have to be careful, and linear algebra do not assume things like this. You have to compute the BA matrix just like the way we did before. So BA will be equal to the 3 by 3 matrix. BA will be equal to the 3 by 3 matrix, and we're going to get the first column of B. Okay, guys, remember now the order has changed because B is the first matrix, so we're going to take the row of B and the column of A. So we're going to take the row, multiply row by 1 by 1, so we're going to have 4 times 1 plus -2 times 3 plus 3 times -2, and this will be 4 plus -12, -8. Let's do the same thing for the other columns of A. So 4 times -2 plus -2 times 2 plus 1 times 3, and this will be -8, -12, and -9. And the last one will be 4 times 0 plus -2 times -1 plus 3 times 3, and this will be 2 plus 9, which is 11. Is that correct? Yeah, it looks good. And now we're gonna go and do the second row. Okay, so we're gonna erase this, and we can start with the second row. So now we're gonna take the second row of B and multiply with each column. So we're gonna have -1 times 1 plus -5 times -2, and 0 times 0 is just gonna be 0. So we're gonna have -1 and -10, so -11. And let's do the same thing for the other column. So we're going to have -1 times -2 plus 5 times 2, and 0 times 1 is 0. So we're going to have 2 plus 10, which is 12. And doing this for the last row, we're going to have 0 for the first multiplication, -1 times 0, 5 times -1, and 0 times 3. So we're going to have -5 for this one. And now, lastly, we need to find the last row. So we're going to have 612. So let's just erase this work and start with the last row. So we're going to have 6 times 1 plus 1 times 3 plus 2 times -2. So we're going to have 3, -4, -1. We're going to have 5 here. We're going to do this one with the second column. 6 times -2 plus 2 times 1 plus 2 times 1 again. So we're going to have -8. And lastly, the last column times the last row, the will be 6 times 0 plus 1 times -1 plus 2 times 3. And this will be just 5. So this is the result of B times A.